here here the question is, how many graphs on n labeled vertices exist which have at least n square by 4 edges? Here it is given that there are n labeled vertices. With n labeled vertices, how many graphs how many graphs are possible? So let us, if there are n vertices which are all labeled, that means there is some way we can identify those n vertices. So from these n vertices we can form how many edges? How many edges means NC2. By selecting any two vertices, we can form an edge. So the number of edges would be NC2 edges. With NC2 edges, how many graphs are possible? In any graph, we can choose one, or if in order to construct a graph, we can choose edges. That means number of graphs are nothing but number of ways of choosing those NC2 edges. So that is nothing but number of graphs would be, we'll be getting number of graphs as, for each edge it will be having two chances. Either it can be chosen or it cannot be chosen. So for each edge there are two chances. Either it can be chosen or it cannot be. So number of choosing those edges is nothing but number of graphs, and that is nothing but 2 power NC2 edges. Here NC2 is nothing but number of edges. And why this 2? Why? Because for each edge there are two chances. Either it can be chosen or it cannot be. So this is number of graphs in which there are number of graphs with n labeled vertices. But here the question is, how many graphs on n labeled vertices exist with at least n square by 4 edges? Here minimum edges is n square by 4. We should have n square by 4 edges at least in that particular graph. So n square by 4 edges is nothing but, at least one n square by 4 edges is nothing but, number of edges would be, number of edges in those graphs should be n square by 4 to NC2. NC2 is nothing but, that means implies n square by 4 to, NC2 is nothing but n into n minus 1 by 2 edges. This is nothing but at least n square by 4 edges. This is the meaning of at least n square by 4 edges. It means n square by 4 to total edges. How many edges are there? NC2. NC2 is nothing but n into n minus 1 by 2. So with if we choose n square by 4 edges, then number of graphs is nothing but n into, out of NC2 edges, n into n minus 1 by 2, we have to choose n square by 4 edges. So NC2 C n square by 4 edges. With this is nothing but number of ways of choosing n square by 4 edges among NC2 edges. So this is here we will be getting number of graphs with n square by 4 edges, minimum n square by 4 edges. So the next combination is n into NC1 n minus 1 by 2 C n square by 4 plus 1, so on up to, it will go up to n into n minus 1 by 2 C. Here we will be choosing all the edges, n into n minus 1 by 2 edges. So this is the equation. This is not, if we simplify this, we will be getting the number of graphs with which contain at least n square by 4 edges. This is for n square by 4 edges, and this is for n square by 4 plus 1 edges. So this will go up to all the edges. So if we simplify this, we know that NCR is equal to NC n minus R. So if we solve this one by using NCR is equal to NC n minus R, we will be getting n into n minus 1 by 2 C n minus R. N into n minus 1 by 2 minus n square by 4. So you will be getting that as n square minus 2n by 4 plus n into n minus 1 by 2 C n square minus 2n by 4 minus 1. So this is nothing but minus of, this will be getting minus of this one. So this 1 plus 1 will become minus 1. So here, that's why we got minus 1. So if we solve, if we go on like this, we'll be getting n into n minus 1 by 2 C1 plus so on. The last term is plus, the last term would be n into n minus 1 by 2 C naught. So this is nothing but, we will write this in sigma, let us write this in sigma notation. So if we write this one in sigma notation, sigma, let us suppose k is equal to 0 to this term is, let us suppose this term as k. So this 0 is going up to 0, 1 up to n square minus 2n by 4. Let us represent that as k. So here k is going from 0 to n square minus 2n by 4. So n square minus 2n by 4, and these terms are added. That is why we are writing in sigma notation. And n minus 1, n into n minus 1 by 2 C k. So here k is going from 0 to n square minus 2n by 4. That's why we represented this in sigma notation. We'll be getting sigma k is equal 0 to n square minus 2n by 4 n into n minus 1 C k. So this is the required number of graphs. So here correct option is option D.